guest here, James Beswick. Welcome to Mintbean. Thank you so much for giving us your time and share your knowledge with us. I understand that you're a developer advocate at AWS. Tell us a little bit about your current role.
Welcome, everybody, and thanks for inviting me. It's great to talk to everyone. I'm a developer advocate now, but I started life out of college with a degree in computer science and business. And I went straight into writing software for a living and learned a lot of C++ and hard stuff at school, and then immediately got into a job dealing with Visual Basic in a bank. And so I fought through some of that. And then over the course of my career, I've worked in lots of different runtimes and PHP, Python, whatever really you need to learn for the task. And then about 5 years ago, I got into this serverless space because we were building software for startups, and we had lots of problems with scale. Scaling MVPs is just hard. And so I discovered this by accident. I went to a serverless conf, and I was really shocked at just how it could be used. I started to get into it, and I spent so much time training our developer groups that I ended up becoming a kind of developer advocate on the side in my role back then. And then this role opened up, and Chris Munns at AWS asked me if I'd be interested, and I started that 2 years ago and love it. It's a great way to share how you can use this sort of technology to move more quickly as a developer. And so, throughout my career, the key thing I've taken away is that development's hard, developers work hard, we don't get more resources, people expect more and more. So any tools we can find in our toolbox that help make the job easier, just make our lives easier. So it's been, that's the short version of 20 years, but here I am today.
Nice. I like what you said about that. The expectations are really high as a developer.
Yeah, and actually one of the things I'll add to that is that what's exciting today is that so many people from different backgrounds are coming into this space, because for a long time it was the computer science crowd. Now we see people from all sorts of walks of life coming in. And the difficulty with solving application problems is actually less and less technical and more to do with people and understanding the mental models of each other and how businesses solve problems. And so having these different perspectives makes a big, big difference to how it used to be, where it was always just seen I think, very statically from one point of view. So from my point of view, I just love the fact that the whole space is growing and we have such a huge diversity of different people in this space. But I still think we're really just at the beginning of this journey that we've still got a lot to do.
Yeah, absolutely.
Great. Okay. Yeah, so basically, just as I was saying, my name is James Beswick. I'm a developer advocate, been a software developer for a long time. I've been a product manager for several years as well. And now I'm a developer advocate at AWS. But I'm really a self-confessed serverless geek. I've seen the power of building these sorts of applications using serverless tools, and I'm really amazed at the power it can give us as developers. The most important thing on this slide is my email address and my Twitter handle. So if you have any questions at all about serverless or AWS in general, please feel free to reach out to me anytime, and I'll do my very best to help. So a few things I want to show you in the deck before I actually get into real life demos, and just a few things to think about as we go into the serverless journey. And the first is Hello World. What does Hello World look like in serverless? I think it's a good place to begin with to see why serverless can be useful to us as developers building things. And then we'll get into some demos and some Q&A. But if you think about Hello World, this always fascinates me because this is the one line of code that we learn as developers. That's really the rite of passage when you pick up a new runtime or some new way of doing things. And you can write it in any language, and it's often the first thing we do. But what does it actually look like as an application? So if I wanted to run a web server version of Hello World, it looks a bit like this. So this is a Node Express server. And if you look at the stack, I've got an actual server or an instance and an operating system, maybe Windows, Linux, whatever I prefer. Then a runtime using Node.js here, but you could use PHP, Python, whatever you prefer. And then a web server. And all of these things that we've got in this stack, they need feeding and watering and patching and maintaining. And when you think about it, I'm just trying to run this single one line of code to do all of this, to get the result you see in the browser on the left. And the rest of this is all overhead. Now, if you zoom out a little bit further and you think about how things work in corporations at scale, imagine that Hello World becomes a wild success and we have to really scale this out. What does it suddenly look like then? Well, now you need to have multiple servers for availability in different geographical regions. And if that brings in security group configurations and VPCs, and you probably need to then have an image of the server so you can deploy more servers quickly if it starts to scale out. And so if the demand is growing, you're going to have more servers. But if Hello World isn't a runaway success, it turns out there isn't so much demand for it as we thought, we'll still need at least 2 servers because of the high availability requirements. So we'll literally have a server sat in another region doing nothing just so that we can be highly available. And we come back to the fact that we're still just running this one line of code. Nothing's changed from the developer's perspective. It's just scaling makes things suddenly very hard. Now, serverlessly, if you contrast how it looks, this is how we do it using serverless. We've got one Lambda function. I'll go through a bit of this in a few minutes. And this contains that one line of code, our hello world. And we put an API endpoint in front of that. And that's it. And the great thing about this is that I can deploy this, and it's massively scalable out of the box. It's highly available out of the box. So if I needed to work in multiple regions, that happens automatically. It can also be made to be very secure. So I can set this up so that endpoint can only ever call that function, and that function can only ever run that code. It can make very granular permissions using access controls and IAM. And so this is really the key to why serverless is so different when you're thinking about building things. You get to focus on the business logic and not the machinery that's running underneath everything. And so serverless can make things very simple. And as an example, I want to focus on web applications because I know that there's lots of things we build all the time. And it's often very clear to understand the benefits looking at that particular type of workload. So if you look at the classic web app stack, and so this could be any sort of LAMP application, you know, Linux, Apache, MySQL, PHP. And so when you consider this sort of application when it goes into production, you have to think about vertical scaling. That's how much each server can do, memory, capacity, and so forth. Horizontal scaling, how many machines are going to be doing this for you. And if you have multiple servers, then you most likely need load balancing. Then you've got to think about availability and security and maintenance, monitoring, and the list goes on and on and on. And at some point, you still have to build actual features that your customers care about. So very quickly, when you build these things in production, you get to an architecture that looks more like this. Now, this is a best practices architecture for WordPress. I picked WordPress because it's really the most popular web application on the internet. It could really be any similar type of app. And most of what you see in this diagram is really handling scaling, availability, the machinery of running the app. And this is really hard to manage without having dedicated DevOps staff and people who understand continuous monitoring and management. And at scale, what happens is that you find that server-bound technology explodes in complexity really very quickly. Now, if you compare that to the serverless approach, this would be a kind of traditional web app architecture using a serverless mindset. Now, everything you see in this diagram is related to the architecture of the app and not the mechanics. And there are some interesting benefits here. So you'll see that we put all of our assets to be served in an S3 bucket, and we push those out through a content delivery network at an edge location. And immediately that gives us global scale for a web app. All of the dynamic interaction of the application goes through an API endpoint to a Lambda function, which talks to data stores like DynamoDB shown here. And so all of this is much, much simpler with serverless, both just from a scaling and operational point of view, but also understanding what your application is doing. So before I worked at AWS, I wrote an article a couple of years ago that got a lot of traffic, and it's the example voting website where I was showing some of these things off. So this was an article that I published on a website called IT Next. And the story behind this is there was a petition at website that famously crashed when several million people tried to vote in it over a 3-day period. And so I set out to build a replacement using serverless, but with certain restrictions. I only had 1 hour to build the site, and it had to handle 5 million votes over 3 days. So I did the math. You know, you've got 5 million votes, 3 days. There's 86,400 seconds in a day. Works out to be about 20 requests per second. And so I put an egg timer on my desk, and I started building out Lambda functions and just building the shell of this application. There wasn't really any time to plan. It's just a yes button and a no button. And the front end's very basic, nothing but Bootstrap. And I even forgot to remove the lorem ipsum in the messages here. And here it is. After 59 minutes of work, I put this up at vote.jbez.dev. It's still running there today. And I left it there just to talk about how you can build these sorts of applications. Now, what was interesting is the article describes how to load test this. So I showed how you can use a library called Artillery to show you with 1200 votes per minute over a sustained period, if it's standing up and you're getting 200 responses and everything's working as you expected. And so everything was great. I wrote my article all as well. But then after a few days after I published this, the internet decided my scaling example wasn't good enough. And so I discovered suddenly when I looked at my account one day at the metrics, and I was starting to get 1 million votes per hour coming through this website. And I panicked because obviously I'd not really built this in any way to be this large. And what was amazing about this is it still worked. And I just looked at the metrics and everything was fine for a long time. And what this really delivered to me, just thinking about how I built these things, was just how well serverless can scale to real life examples. You know, spiky workloads that are the hardest ones to manage, where traffic appears out of nowhere and you don't know what to expect. Traditionally, in a server-based environment, it's really, really hard to get this right. So seeing this survive the onslaught from the internet really opened my eyes to what you can do with serverless. Now, when I built that app in my 1 hour, there were certain things I didn't have to do. And there's actually a version of this slide with many, many more things on it. The list of things is actually pretty remarkable when you come from an instance-based environment like EC2, where you're building where you're managing virtual instances. Now, obviously, there's lots of different ways to scale applications, and not every single app needs to scale. So how else can serverless be useful to you as a developer? Well, a common challenge that I've found as both a software developer and a product manager is around gathering requirements from your users. Now, the big question is, when do you know what to build? So are you in an organization using waterfall, where you know all of the requirements that you want to build up front? Or do you discover at the end of the project? I hope not, but definitely that is something that happens. Or do you discover the requirements along the way, that as you're building things, you're just feeling out what the thing needs to do? Or do you find that you've got a project where there's no end to it? It simply just you keep receiving features from customers and you keep building those out. Now, increasingly, I think what you tend to find is the last two options here are becoming the way that we build things. You know, the waterfall idea on the far left is something that's fairly dated now. People have generally accepted it's really hard to know about a project at the beginning when you know least about what you need to build. And so these last two are creating an environment where, as developers, we've got shorter and shorter delivery cycles, and we need to iterate more quickly in terms of doing these things to meet our customers. If you think about mobile apps as being a good example here, many of the apps on your own phone may receive updates a couple of times a week because they're simply receiving feature requests from customers and delivering those as quickly as possible. And they clearly had no idea about those features when they first built the app. Now, in the traditional application architecture, making these decisions early can create inflexibility. And many of us have been there, where you built out an architecture that simply doesn't do what it needs to once the app starts to meet the users. So it can be very hard to architect at the very, very beginning when you're building things. So why is it that serverless really helps with this problem? Well, one of the reasons is there's a lot less code. So because your code is focusing on business logic and not a lot of the undifferentiated heavy lifting, connecting to databases, doing auth, this sort of thing, the boilerplate, typically a lot of the projects we see have 50 to 70% less code. And projects with less code often can be more nimble when you need to make changes to them. Also, there's microservices are typically more nimble than monoliths. So monolithic apps are more fragile, and the larger they get, often the more fragile they get. So many of the companies out today, some of the largest companies in the world, are still working on mainframes because they've got these enormous monoliths that are managing their businesses, and they can't change them. They're terrified to really change things because it's just very, very fragile. When you look at how serverless apps are built, they're service-based. So you can actually use services for common tasks. And so we're not reinventing the wheel all the time. So many repetitive tasks, like the auth, database handling, session management, all this sort of thing gets handled for you. Also baked into the platform, you get things like monitoring and logging and tracing. That saves a lot of time. And then CI/CD, which is slowly becoming more common, continuous integration and continuous deployment, where you have multiple versions and stages of APIs and services. We have lots of tools in serverless that makes it a lot easier. We've got CloudFormation and tools like Serverless Framework or SAM. So to see agility really helps to understand what the serverless app looks like in practice. Now, you've probably heard of Lambda, and this is the functions as a service offering that's the heart of what AWS offers in serverless itself. You provide the code, and the Lambda service will run it on demand for you as needed. So Lambda can do cool things like this. We can give it this piece of code here, and what you've got here is a node snippet that takes an input from the IoT button, the physical button that you would press, and it publishes it to a downstream system. So every time that button is pressed, this code will run, and this code increments a counter in the database. So what we've now done with this few lines of code is we've built an IoT app where if we had a display in a customer space, it could perhaps tell you which number of a customer is being served. But really, more generally, this is what Lambda can do. It can be triggered by practically any type of event. So it might not just be an IoT button, it could be a file upload, or an HTTP request, or a scheduled cron job, or another service within AWS, or a SaaS partner. The list goes on and on. And then it can also interact with really almost anything within AWS or the world that's connected to the internet. And so when you think about it in this context, Lambda is more like glue. And so it's a mechanism for taking data from one service, manipulating it, and then putting that data somewhere else. So when you think about how Lambda works, it can interact between services like API Gateway and DynamoDB. So you have an API endpoint and a database. And just by itself, these three services, you now have an API for a CRUD application, a create, read, update, delete application that's massively scalable and gives you high throughput out of the box, all with very, very little code. But you can just as easily make it do other things too. So you can have that Lambda function store objects durably in a service like S3, which is an object store. And then maybe it's written a photo or something into that bucket, and you could serve that out to the world through a fast CDN like CloudFront. And maybe when something arrives in that bucket, that itself is an event. So you might want to have an image then sent to recognition, which can then interpret the results of what's in the image using machine learning and write that information back to the database. And then that database itself can then trigger another Lambda function when data arrives to the database. So that might, for example, send an email to a manager or an internal user or a customer, or it might send the message off to a queue to be processed by another system. And as you start to build up these applications using these services, what you find is you start to write less code, you create a resilient distributed infrastructure, you create a clearer architectural map of what is going on, and you start to provide more capabilities to your applications. Now, I mentioned that Lambda can connect with almost anything in AWS, and really, even as an AWS employee, it's a challenge to keep up with all of our services. There are simply so many. But it gives you real access and power to anything within AWS, the full power of machine learning, for example, or IoT, if you want to build an IoT application, and analytics or media processing, or if you're building web, mobile, and digital services. There are just so many services you can use for each one of these categories. So let's look a little bit more about how to use serverless. So there are really some common serverless application types that we see customers use, and there are currently millions of customers using Lambda. These are some of the most popular. So web apps are really popular for building static websites or complex web apps or single page application backends. Backends themselves for apps and services, mobile and IoT. Data processing is huge. If you've got MapReduce jobs or batch jobs or chatbots or anything like that, anything that actually processes data, this is a really good use case for. If you've got an Alexa device at home, then you're already using serverless because when you speak to it behind the scenes, it's actually using Lambda to process the instructions that you give it. Or just IT automation, when you look at policy engines or extending cloud services or infrastructure management, these are all event-based things, so they're a really good fit with serverless types of workload. Now, just to give you a kind of preview of some of the best practices that I've seen since I've started using serverless over the last few years, generally you want to avoid lift and shift. So transferring a server-based app to a Lambda function generally doesn't give you all of the benefits of serverless. You want to focus on the application flow and integrate with serverless services. You want to really focus on events, the events that trigger things in your workflows. Remember, functions are really ephemeral and they're stateless, and they come to life in response to events happening. So if you build a flow chart, often it's very simple then to take the flow chart and turn it into a serverless application. You want to think about keeping functions small. And sometimes as a developer, this is a little bit odd because, we're paid to write code. And often your functions may only be 20 to 100 lines of code. So you're writing a lot less code than you're used to. So if you're writing very, very large functions, really you want to try and look at breaking them down further. It makes them more testable, makes your applications more extensible typically. So you want to avoid these monolithic functions that we're so used to building in the server-based world. So I like this phrase that code is a liability, especially my code. And so the less code I have to write, generally the better the application is going to perform in terms of reliability and testability. Also, you want to be thinking about using the right tools for the job. So, you look at all these services, it's a very rich toolbox of different things you can use. One of the really interesting side effects of building things with serverless is you don't have to commit to one runtime. So, typically you work on a project and the whole team, they could be experts in .NET or Java. So an application is built that way. But in real life, often some application parts will be well served by Python, others by Node.js, others by Go. Well, in the function-based world, you can have a mixture of different runtimes for each task. It's perfectly normal to do that. You make it a lot better for the performance of your application. I like to also think about code as plumbing. So, many new serverless developers start to go into the model of building very large functions. But again, think about how you're connecting services together, not writing code that just stands by itself. And then also starting down this journey, because it's a bit of a mental paradigm shift, you want to find something that's a simple place to start. I started with cron jobs. So those are the things that fail at 2 in the morning. They wake you up because a database report hasn't been sent or something like that. So, getting rid of those types of jobs is a good place to learn the skills and then progress to more complex apps where you can use serverless with multiple services. And so that depends on your team and your organization for the right place to start. And what I found when I first started using serverless was, not all applications should be built using serverless, but typically I found that some part of all workloads could be serverless. So a good example of this, if you think about real-time gaming systems like massively multiplayer online systems, you've got this real-time gaming chat, which really you do need to have some sort of server-based system because it's extremely low latency, but all of the account management and the leaderboards and all the other things that administer the whole game, those often can just be built using a serverless approach. So one of the things I think is really a key takeaway is that really this revolutionizes how you can develop scalable applications quickly. And I use this word really carefully because serverless is not an incremental change in the way we develop things. It's actually a revolution in the way you think about developing applications. And I think you'll see the incremental work over the years where first we had the cloud with EC2 instances, then there were systems like Elastic Beanstalk that enabled you to package applications. Then we moved towards the container-based approach that really created much more abstraction between on-prem and the environment you were deploying to. And really this is the next step in the whole journey to get rid of all the stuff that you don't need to think about. So it radically and fundamentally changes the way that developers work. And part of this comes down to these 4 factors that we're thinking about. This agility factor is really something that as developers we have to think about a lot. How fast can your software change to meet the needs of your users? Users increasingly expect you to be able to keep pace with what they want. And part of that comes down to the explosion in mobile apps and consumer interest in technology that's accelerated this too. So with serverless, you have this less code and the fact that apps are this federation of services. It makes things more lightweight and easily interchangeable and reduces the amount of infrastructure you have to think about. Now, scaling is another factor that is just an incredibly hard engineering challenge to solve. Some applications in the world now have tens of millions, hundreds of millions of users, and this creates uniquely hard problems that create vast engineering complexity. And so when you work in a startup or you work in an enterprise and you're scaling to tens of thousands of users, these are really tough problems to solve by yourself, especially when you have problems with spiky traffic. And for startups, this is where I came from before this. It's an even harder problem because by definition, you build MVPs, minimally viable products. And the idea of an MVP is you're testing with the market if something is a good idea. Now, by definition, you're not building it to be scalable because you just want to test the idea fast. But what tends to happen is if the idea is good, it takes off very quickly and you get caught short because you haven't built it to be scalable. And at that point, then you lose users because your application is not as reliable as it needs to be. So this, for me, with the way I found serverless, it really helps solve that problem in particular in the startup world. Cost is another thing to think about because building systems is expensive. You've got hardware, data centers, operations. There's many, many hidden costs along the way, especially in companies where you've got networking and security and massive numbers of headcount and people working on things. So cloud really does help enormously, but you might still be paying for more than you need to. And that's because so many virtual instances aren't running at 100% all the time. So in all those virtual instances, they still need your maintenance and management too. So with serverless, what you find is the cost of it is generally proportion to the usage. And that makes it also easier to apportion costs to individual customers. You better figure out which one's costing you the most money in your infrastructure. So one of the great examples here is A Cloud Guru, who recently were bought by Pluralsight. So about 18 months ago, when I chatted to them, they built their entire infrastructure where they scaled to 40,000 students in 6 months with no servers. And they have well over 1 million students today that have completed courses. So when I spoke to them about 18 months ago, they told me they had 43 microservices, 287 Lambda functions with 7.7 million invocations per day. And this entire platform was costing them less than $10,000 a month. So, in terms of both the startups and enterprises, serverless applications can be extremely cost efficient if you build them in a well-architected way. And then finally, just something to think about, and I think about this a lot, is the environment that we operate in as developers. There's just this huge, huge pressure for engineering talent. And you need incredible things being built by very few people. So we have small teams of people these days. Often we're expected to know really everything. You see jobs that are DevOps, DevSecOps, FinTechOps. You've heard of the 10x developer and all this sort of thing. And so serverless really lets those small teams do a lot more because it takes away a lot of the heavy lifting issues that really don't help you do your job and lets you offload common functionality, lets you focus back on building your software. Now, just before I get to the demos, I wanted to show you a couple of other things here that often people aren't aware of. We have something called the AWS Free Tier, which I recommend just signing up for. It gives you a lot of free access to a lot of these serverless services. So with Lambda, you can invoke it 1 million times a month for free. That's forever. S3 has free storage, DynamoDB, and there's about a dozen other services that didn't fit on the slide. But definitely sign up because the easiest way to learn this stuff is just start building things and seeing how they work. And also, before I move on, if you need to look for serverless learning resources, look no further. We've got a website called serverlessland.com, and it's built by the DA team that I work on. And what we've done is we've pulled together all the blogs, videos, learning paths, and resources to help people start and see everything about serverless. So it's completely free. You can go there anytime, and we keep that up to date at serverlessland.com. So what I'll do now is I'll switch over to the demos so you can see a little bit more about how this works. So there's two things. Now, also, I just want to mention we've got questions in chat. So I'm going to just show these demos. I'll be taking some questions from you. So feel free to ask anything you like, and I'll come back to them in just a couple of minutes. Actually, one question from Navi. Do you want to pause and answer some questions? I can absolutely do that now. If you want to ask me any questions now, I can definitely jump into any topics that you like.
Sometimes it can be, sorry, James, I just wanted to jump in. Sometimes it can be intimidating to ask questions. Guys, feel free to drop them in the chat or just if you want to open up your mic. I know that was a lot of information and James is an expert on serverless. He understands this information so well and the domain and all the problems it has. Before he jumps into demo, let's take a minute. Did anyone have any questions about any of the stuff that he covered? We have Ken raised a hand. Ken, feel free to unmute yourself.
Yep. So for serverless, in regards to, you were talking about the possibilities of, say, hosting a static page on serverless. For somebody who's just starting out in regards to it and doesn't have a lot of cost, have you compared the cost to, say, a web hosting compared to serverless in regards to what the difference is?
Yeah, I mean, each workload is different. So it depends at what scale you're serving things. So yeah, we've got lots of small sites that you could, frankly serve anywhere, and the cost is going to be fairly negligible. But once you get into these larger sites where you might have 100,000 users a day or more, that's where you start to see the difference, because it's this total cost of ownership problem that gets you. On the smaller scale, you can go and find the $10 a month web host, and you might be fine. As you start to get into the requirements where you need to have higher and higher availability, or you need to have certain management aspects where maybe you've got users all over the globe and you want to have low latency for everybody, no matter where they are, that's where it becomes harder and harder to really compete with the serverless approach. And so it's, doing the math is one of the hardest things with this, because basically I recommend each workload, you really stand up the cost list. Look at your hosting costs, look at your headcount costs, and then really do a like to like to see where they are. But we definitely see a lot of customers who take this approach because it can just be incredibly cost effective. And I'm about to show one of the web app ones in a minute, so it's a good place to start.
Okay, thank you.
There's a question here: how is Fargate ECS different from AWS Lambda? Yeah, so ECS and Fargate basically is another type of abstraction. Right? If you want to run containers, then that's a great service for you. And really, these things don't run in competition with each other. They're things that you may use sometimes for some workloads and sometimes for other workloads. Really, where Lambda comes into play is that if you've got things where you don't want to manage what a container will give you access to, operating systems, these sorts of things, if you've got no reason to, then I'd recommend looking at Lambda. And Lambda is especially helpful when it comes to scaling events. So often when you look at EC2 or container-based systems, although they can scale, they can't scale nearly as fast as Lambda. So in my experience, you never survive your first scaling event. What happens is you think you understand what's going to happen, and then the traffic arrives and you learn from that experience. With Lambda, typically, because of you're looking at scaling within hundreds of milliseconds, that tends to be a lot easier. Can I share the code behind the voting apps? Yes, absolutely. I'll dig out the code at the end of this and I'll paste the link. It's something that I published in a GitHub repo, and I'll put that out for you. What's the difference between AWS and other services like Heroku? Yeah, Heroku is a great service. There's a lot of alternatives out there. I would say, before I worked at AWS, the reason I chose the AWS platform was simply the range of different services. And under the covers, you've got security elements like IAM that they're incredibly powerful and give you a lot of safety as a developer if you know how to implement them. So it's something where if you have something that's very simple in terms of just it's not doing much, or the voting app is very simple, you can really host that anywhere, whatever you prefer. But I think as you get into more and more complex apps, you're thinking about the range of other services you might need. And generally, you want to make sure you have a provider that's got those services. It's kind of difficult really to connect services across different clouds. I know it's becoming a hot topic, but in practice, when you're building things, you tend to want to pick a platform that can do most of what you want. And there's one more question. And really, there are no dumb questions here. So basically, I really believe that I think if you have a question in your mind, just ask it, because there's a reason you have a question in your mind. And this stuff is a little bit strange when you first get your hands around it, because like I tend to find the best way I learn is try to build something. And especially something that you've got a passion for. You've got a passion project you want to build a solution for. It can be a really effective way just to get to grips with how these things work. Since Lambda scales quickly, how can we handle DDoS attacks? Yeah, great question. So when you look at DDoS attacks, these are really difficult because you can often get an enormous amount of traffic from different IP addresses. And if you try to manage them yourself, it can be really tough. We see I've worked in places where we've tried to do it ourselves. You tend to have a lagging response to DDoS. They tend to be able to take you down and then you respond to it. But one of the benefits of being inside the Lambda environment is you're inside an environment with all the other AWS customers. And so there's an enormous amount of networking security that happens that's totally invisible to you, that's designed to handle all of these attacks that happen, and you'd simply never know about. Now, if you have a public endpoint, like an API gateway endpoint is completely open, then obviously the steps you can take there to minimize what I call denial of wallet attacks, because typically AWS infrastructure won't fall over. It's just going to scale depending on the traffic. So you want to, if you've got malicious traffic, you want to take steps to block that. You can use services like AWS WAF, for example, or another very simple one is CloudFront. Just put that in front of API gateway and can provide you a lot of protection. But yeah, it's something you have to think about when you have public apps out there. Well, what I'll do is I'll jump into this app very quickly, and we'll keep some time at the end. But what I wanted to show you here is, I'll come back to May's question also afterward. What I want to show you here is a simple web application. And so what you can do with this is I've got a website here that you can go to, and it's just called website.jbez.dev. I put this up at reInvent last year. Talk about passion apps. This is one of mine because it's a conference. Everybody wants to say hello to me. I wanted to tell people where I was, so I put this up there. And this is the good example of how this can work. And so what you can do with this is I've got this application, and it's got a front end and a back end. Now, let's look at the front end first. So this is a Vue.js app. And although there's a lot of files, there's really just one component that's doing the work here. And if you look at this in comparison to the site itself, you'll see that's my picture and the cowboy hat just there. Those are the headlines. And here's just the layout of the page when it fetches data that's going to render on this display. So you've got a table of information just here. And then at the bottom of it, this is the magic that essentially we're using a library called Axios, which is going to go and fetch the list of data from this API gateway endpoint and produce this list. And then all this code's going to do is load that list into the page, and that's it. And so that's great. This is, what, 70 or 80 lines of code really to do something. So how do I then get this application out into the world? So I can run it locally on my machine using npm run serve as I can with any of these types of single page application framework apps. But we have a service called Amplify Console that can really simplify this. So all I do, I've deployed this already just so we save time, but I put my website into GitHub, and I put all those files that I showed you from here. I've just basically just uploaded them to GitHub, exactly the same. And then I tell Amplify Console to look at this GitHub repo. It knows to be monitoring this repo. I tell it about the domain setup. I want to have a website of my own with my own domain name. It manages the SSL certificate for free, so that's something I don't have to think about or configure. And what this does is every time there's a change to that repo, it goes away and runs the npm run build command and puts the website on S3 served by CloudFront. And that's all invisible. It just does it for you. Now, to show you how this works, I'm going to do something in this site and show you the change immediately. Where if we take this, where's James at reInvent? I'm not at reInvent anymore. So that's like, where's James this year? I'll change that there. Now what I can do is I've just made a minor change to my code. So I do run git status. You can see it's detected as that one code there, one code change. So I'm going to say, I want to git commit my minor change and then push that to GitHub. And so if you know how to use GitHub, it's the same process as you use whenever you commit your code. And my code will now be, if I just refresh this, you'll see that now 13 seconds ago, I made a change in that directory. Now, what's interesting is that Amplify Console in the background detects the change on the repo and then goes away and starts building that. Let's go to, and you'll see over here now, it started to provision an environment and do the build process, which is typical for a single page application framework. And you'll then do that build and deploy that and verify it. And the typical process takes about 2 minutes with something this small. One of the great things about this is that if I've got a more complicated app and I've got some bugs in my code, if something goes wrong with the build, the old version stays live. And if the new version passes all the tests, then it will be available on this site. So I can essentially push this out. It creates a very simple CI/CD workflow to publish the application. And this is something that immediately can withstand a massive amount of traffic because of the way it's served. Now, what that builds, what I'll show you very quickly is the back end to this, because I mentioned it gets that list of events that I'm going to. And so I've got this application on the back end. So let's take a look at that while the front end is deploying. Now, the back end, we use this language called CloudFormation, and there's a tool called SAM. And SAM makes it easier to build serverless resources using code. So I've got my database table here using DynamoDB, so I specify that there. I've got my one Lambda function, and what that's going to do, if I just open the code, all it's doing is it's querying the database to get a list of my sessions. So just really making a database call and returning the results. And then in there, this is the permission that I grant to the Lambda function to be able to access the table. And this part here sets up this HTTPI endpoint so that I can then reach that from the outside world. So in that 40 lines of YAML, it creates those 3 different services to be able to maintain everything that's going on. Now, if I then go to DynamoDB, which is one of the resources that I deployed, what you'll see here is I set up this one table here already with this one entry, the introduction to serverless event. And if I refresh this, you'll see that this is the one item that appears there. So if I make a change here, you'll see this is live. Introduction to AWS Serverless with demos. Well, let's add that. So I'm just changing the result in the database. And then if I refresh over here, you'll see that change is immediately there. So it's actually a dynamic table. You see also now that this has changed to where's James this year, because the front end deployment is now complete. And so this application is really, only a couple of hundred lines really, and most of it's just boilerplate from a Vue.js install. But this can sit there and I never have to touch it. It's a website that shows you where I am. I just have to remember to put data in the table, but otherwise, that's how you would build a dynamic web application. That's a very fast demo, I know. So it's just to really give you a flavor of what you can do with the web apps. And one other thing I want to show you really quickly, and then I'll go back to more questions. We talked about scaling, but scaling can be one of those topics where it doesn't necessarily make much sense until you see it. So I wanted to show you what I meant by that. And what I have over here, I've got a Cloud9 instance, and this is like a virtual IDE that's running in the cloud itself on an EC2 instance. And so I've got this environment where I can run Linux commands. It's really just like a Linux box in the cloud. Now, what I've built is this one function that I'm going to use to resize photos using graphics magic. This is a really common process if you build web and mobile apps where you're uploading user data from cell phones. And one of the things you find when you build these types of apps is that if you've got a server-based environment, and you get lots of uploads, it takes a lot of resources. There's a lot of network bandwidth, a lot of activity going on to better process photos. So it's a really good serverless use case for handling media and reprocessing it. So you'll see here, this Lambda function, all it is, it's about 50 lines of code, a lot of boilerplate. It's going to read an object from S3, which is where we store the photo. It's then going to use graphics magic to do the resize of the image. And then it's going to write that object back to another S3 bucket. And so what happens here, if I uploaded one of my Google photo albums, and these are all from cell phone photos, so they're all between 3 and 10 megabytes in size. Now, if I upload any one of these images to my S3 bucket, what I can do is this. I can say I want to upload, just to look up the name of my bucket, if I can remember it. I've got this bucket called resize source I'm going to use. So this simulates an upload from a mobile app. But what happens is now you'll see in my S3 bucket, there should now be that file, this one JPEG file that was 4 megabytes. And if I go back to the destination, what we'll see when that's processed is 60K. So that's finished the processing job as you would expect. But what happens if we really slam this process with a lot of data? And this is really where it starts to shine, because if you go back to my S3, so my Cloud9 instance, this code doesn't talk about scale at all. It just talks about the resize operation. It's simply doing the resize and exiting, nothing else. So what I did here is in my photos directory, I've got couple of hundred large images. Let's see how many I've got. I've got 158, so quite a large amount of data. So what we could do now is I'm going to upload all of this to my S3 bucket at once. And I'm on an internal network here because I'm using Cloud9. There's about a half gig of images. So I can really load these into the bucket incredibly quickly. So let's try it out and see what happens. Oh, I didn't type CP. So you'll see this is loading this 600 megabytes of data. And it looks like it's going to be done, what was that, 10 seconds or something like that. And if I go to my S3 buckets where we uploaded those, first of all, we see in the source bucket, we've got a half gig of information that's loaded up just there. So that's all the data there. And if I go back to my other bucket, my destination bucket, what you'll see is I've got all the objects there and they've all been resized as you would expect. So what happened? So typically, if I was to take a half gig of data like this and launch it all at a single server, at some point or another, I'm going to provide too much data for that one server to be able to keep up with. And the users who are uploading these photos will end up seeing that they get rejected because the server can't keep up. But in this environment, I can simply upload as many tens of thousands of images as I need to at any point in time. And it simply keeps pace with whatever I throw at it. And how that works, if you look at the image resizer function, this is our Lambda function that we just used. This is the CloudWatch metrics tab that tells you how many invocations, how many times the function was called. And what you see here is that this was our single invocation when we uploaded that one photo from earlier. So one invocation, you see it took about 1.1 seconds to run its task and everything else, and it's got one concurrent execution. Sometimes it takes a couple of minutes for this to come through, so I can show you what I did earlier. If I go back 12 hours, what happens here is you can see that when you get a lot of traffic, it will start to scale up. So let's wait for this to come through. Here we go. So now you can see a few moments ago when that happened, we got 158 invocations. That was the number of files we saw in that bucket. And we saw that with that, there were 77 concurrent environments that it created to keep pace. So that's like having 77 completely separate servers running completely separate versions of that function. And on average, what you see there is that some of those invocations took up to 3 seconds, but on average, we're looking at about just over a second to process each image. So when you use this type of environment, you can scale up so fast. It's a fantastic way to keep up with applications that run at scale, and when you don't know the amount of traffic that you're expecting. So I just wanted to give you a quick example of how scaling works in real life. As you can see, I didn't do anything in my code. It's just something that happened when Lambda responds to the traffic that arrived in this case. Okay, so I'm done with the demos, but happy to answer any questions. So I'll go back to May's question over here. If I want to become a back-end engineer, do you recommend I still focus on and learn serverless services? Yeah, I do. So I think serverless is really interesting depending on whether you're coming from the front end or the back end. So for back-end engineers, I think it's actually very easy to learn because often they have good understanding of distributed services and a lot of the mechanisms that are used to manage traffic. And I've said a few times to people that I think serverless is really like automation for back-end engineers and people in the DevOps space. They find it very easy to grasp. At the same time, I actually think it's pretty good for front-end people too, because when you look at a lot of front-end devs who come from the JavaScript space, they're very, very sharp about understanding events. You know, everything happens in browsers tends to be an event. And so you understand the event model of how things have to flow. And really the step to the back end where that happens is logically much more straightforward. And because a lot of the things that are typically difficult, like VPCs and security groups, all these things are abstracted away in this environment, I think it's fairly easy for front-end devs to pick it up too. So how does the app runner service, is it going to use, how it will work in a serverless manner? Yeah, so app runner is another flavor of abstraction, much like with ECS and with containers. And so if you have apps where you need access to ports on a server, for example, you might find App Runner is a better place to run your application. There are some limitations in the way Lambda gives you access to the environment. So Lambda always receives an event, for example. It doesn't give you access to ports. You don't have any actual access to the machine that the Lambda function is running on. So if you've got an application where you need something longer lived than 15 minutes, for example, then you may find that App Runner is a good fit for your workload. But definitely, the more of these services you know how to use, you can kind of mix and match the things you need depending on how your app fits together. You're welcome. Yeah, the scaling example is an interesting one because I think asynchronous workloads are something that are generally not so well understood by people. And so, I talk to a lot of developers who try to build things synchronously all the time. And I think increasingly, a lot of the things we walk into, especially in the mobile app space, end up being very, very hard to manage synchronously because of the scaling aspects. So you think about when you use an app like Lyft or Uber to find a car, it doesn't work synchronously. It puts your request out there, it finds drivers using a range of different services in the back end and responds to your phone asynchronously over WebSockets. And so asynchronous workloads are becoming something where the more you understand how they work, the more powerful your app can be. And it just turns out that asynchronous workloads are a great, great fit for serverless because of the way that these apps are architected. So the image uploading example I showed you is entirely asynchronous. Behind the scenes, there are queues and things making it all happen that you don't even see. But if you design the app to work asynchronously, it gives you enormous power in handling things when you get massive scale coming through. Is it easy to switch from hosting, for example, on GoDaddy and then move to serverless as your app grows, or should you start developing on serverless from start? So yeah, I think generally I would say start where you mean to end up, and that's true of any platform. If you're building things in a greenfield environment, it's generally easy to pick the environment that you want to be in when the app is finished. In real life, I know that's not realistic because often requirements change, things change beyond your control, and you often end up migrating. But in terms of migrating any type of workload, it's not as easy as building greenfield workloads because you have to really understand how the app was written. Now, if you've written the app, that's less of a problem, because often you know the mental state you're in when you decided how to build it. Often you're picking up work from other teams and they didn't leave documentation, maybe. And so you've got to work out how an app was built, how it was engineered, and learn it that way. And so there's a lot of learning in the dark with migration that can be fairly tricky. So I'd like to say that migrating apps in any environment could be easy, but it's really one of the hardest tasks, I think, when you look at these sort of corporate IT jobs. In my opinion, what's the future of serverless and how fast do you see developers migrating to serverless? Yeah, so what we've seen in serverless is this massive adoption. I mean, there's millions of Lambda customers. Amazon.com itself is a customer of AWS and a customer of Lambda. And last year, over 50% of all of their workloads were built using serverless. So, they're a very tough customer for us. They choose technology based upon how it performs, how reliable it is, how secure it is, how it scales. And they have these massive events like Black Friday and Prime Day. And so they've been a big driver in this. But we see massive companies as well in really all types of industries, from finance to healthcare to media to sports and entertainment, using these types of services. So my feeling is that the easier we make it for people, the more they adopt it. And really the mindset has always been with this is to continue making it easier and easier and easier. So people often ask me, what's on the roadmap at AWS? And it isn't really a secret when you think about how we think about that, because generally we want to make it faster, cheaper, better. And we want to be able to make the tooling better all the time for customers. And obviously serverless is still fairly new, even though it's 5 years old. So we've still got a ways to go on lots of things in terms of just making it ever more easier. But that's really the future direction that we're taking it in.
Excellent points, James. There was a question from Prashant that I believe you missed. Could you please explain a bit about what step function abstracts?
Yeah, so that's a good one. So step functions it helps you with orchestration. And it's not necessarily just serverless orchestration. You can use it with containers and other things too. But this is one of these difficult topics of problems that you don't realize until you get into one. And so my first experience of trying to write my own orchestration was working on a trading floor where we were building a trading system that settled trades. And when you think about what can happen with a trade, lots of things can go wrong. Sometimes they complete, oftentimes they don't. Funding can fail. And there's lots of things in real life that are like this. You think about e-commerce transactions with credit cards. A credit card can work, it might not work, you might need to do refunds. There could be problems with your inventory. And there are all these flows in these applications that if you try to write them yourself, you get into spaghetti code real fast. You get if-then nested statements all over the place, and it becomes very, very hard to test and maintain. So this whole space of orchestration is really for this class of problem where you have very difficult workflows, and often they can be things that are not instantaneous. If you've got a payment process where a check clears, that might be several days, and somehow your system has to remember the state of where that one transaction is while also managing all the other hundreds of transactions. And so step functions is designed to solve that sort of problem and give you enormous power in terms of just building versionable workflows and things you can very quickly flip in and out. And so my first experience with step functions was another aha moment, because it took away all of my spaghetti code and also made it so that I could express in JSON, just what the flow was. And then when I had version 2, because of course it always changes, I could then implement version 2 while step functions also remembered which transactions were still running in version 1 and kept those going. And so people often don't know what it does initially, because you might think you could use it for something like I showed you with the S3 image transform, but that sort of task is generally too small for what step functions is for. But if you have something that's longer lived and complicated, I would definitely start there and start building out your workflows and step functions.
Nice. James, thank you so much. First, I just want to mention, I think it's really important to play around technologies that are exploding. And like you said, it's only been around for 5 years. Experimenting with tools like this kind of gives you that edge. You did mention that there was a free tier, I believe, that you can explore with.
Somebody told me the other day there was something called AWS Educate, like I wasn't aware of before, but I would definitely look at that to see what it offers. One of the things with free tier is that it's fairly generous in terms of giving you access to lots of different services, but there's also no upper bound, because the idea is that we don't want to stop you if you scale. And so if you use free tier, the safest way to use that is to use a CloudWatch alarm, so that if your bill goes above 1 penny, for example, you'll get an email so you can figure out why you're being charged. So with free tier is something that I think is usually the better place to start with for most people, but just make sure that you put an alarm on the bill so that nothing happens without you knowing, why you're being charged in the account.
Oh yeah, I've heard some horror stories, so be careful with that, guys.
Yeah, it's definitely something we're thinking about, because with these pay-as-you-go services, the benefit is that you pay as you go, and the downside is you pay as you go. So there's we've talked about ways of providing more guardrails for people without limiting them when they legitimately need to scale up. So I imagine you'll see more and more of the features evolving in that space.
That's fair. I really, really, really appreciate everyone being here, and super grateful to this community and speakers like James who want to come in and share their knowledge. I think there's a lot in the serverless community.
Yeah, it's definitely a difficult thing to learn initially, because it does touch on various things, but I think with lots of these things, it's just jumping in and building something is the best way to get your arms around it. And then when you get stuck, let me know, and I'll do my best to help you. But it's I'm really excited about how it's grown, and the community is extremely friendly as we're learning how to do things in the best way. So one of the most exciting things has just been seeing the community grow and stay really positive around the technology.
Yeah, absolutely. I'm actually a little surprised that you're sharing your email. Not a lot of people do that. So
crazy, isn't it?
Yeah, it's crazy. How many people actually, like, out of curiosity, like how many people actually end up sending you an email?
Quite a few. It's I get questions from a broad spectrum of different things, but part of the job as a DA is to help people understand how to use these. So I can't help people with specific questions in their account because I can't see what runs in their account. my access to things is very much like a customer, but I'm happy to help people as they're learning, when they get stuck with particular problems and seeing where they are and helping them with resources to get them unstuck.
That's very kind of you. Like I said, we've had, oh gosh, hundreds of speakers come in, and guys, it's very rare for someone to share their email. So I'm encouraging you all to send James an email.
Definitely. I mean, please do. It's I'm really very interested to see what people build, and part of the best, we build things that our customers ask for, and the easiest things to know about how customers are building is to talk to them regularly. So yeah, don't be afraid. Ask me anything you like. There are no dumb questions.
Thank you for that. Appreciate it. All right, guys, thank you so much for spending Monday afternoons with us. As always, super grateful. If you haven't checked out the Mintbean community, please, please, please check it out. Probably one of the warmest professional communities out there. So yeah, check us out. Take care.
Have a great one, everyone. Thanks very much.
Bye, James.
Bye.